say it. I get really excited. It's gonna be a fun day. What's up? I said, I didn't give you guys chapter 6.
No, you did not,
Okay.
sir.
So, sir, print out chapter 6 for you.
Thank you.
Chapter 7 coming.
Wait, chapter 6, what? Chapter 6,
Chapter
no?
6 of the lab.
Lab or actual
Lecture.
I'm not going to lecture. Computer fine.
That's right. You really don't need it because, you know, you guys can just listen.
You gave us 6.
Okay.
What are the lecture notes? Is it on campus? Like the policy?
We sure?
Yeah, it should be under. Or it'll be under.
Where is it?
I also print them out.
You guys can make cute babies. Oh, like that. Oh, you guys are good at kids? You do? Even though they get
Okay, I'm
them.
not giving you guys lecture notes today. Today you're gonna take lecture like normal college students, right? For the first part of it, and then we'll take a break and then I'll give lectures. But you won't need them for it because, you know, you guys are just gonna pick this up.
Yeah, I don't have a lot.
It's not as difficult. Right? So you gotta write stuff down. Oh my God, God forbid. Please make me write stuff.
These are horrendous.
Okay, so chapter 6, yes, this is chapter 6. So it's called chemical nomenclature. In other words, you're going to be able to name chemicals. This is a very important part of chemistry. You should be able to name chemicals. It is not too difficult. As long as you apply the rules that we talked about. Okay, are we ready?
Sound out.
It's not even right. When you cut it, you keep putting.
Chemical nomenclature.
You still got the habit. It's like when you take your glasses off and you don't.
So my hair used to be like down to my shoulders. I still have the habit for all that time. And it's like, it's annoying because it just looks weird.
It'll take
It's
us
like,
15
that
minutes.
shade, what is it, fade? You keep doing it.
So sad.
No.
Tired?
It's okay, Mama, you got this.
Okay.
I'm very motivated.
Okay, so you guys already know about the chemical formula. You know what the substrate is? What is the substrate? Number of what? Number of atoms. So in the case of H2O, 2 is our substrate. That means that we have how many atoms of hydrogen? Of hydrogen? H2O, right? So that 2 means we have 2 of hydrogen, right? Been gone for a while, huh? Okay. So in the case of sodium chloride, we know that we have 1 sodium and 1 chloride because the 1 is understood, right? You guys knew that, day 1. Good. So we also know that we have the 2 letter or single or 2 letter symbols for our elements, right? So we have like S is for sulfur, Li is for lithium, Na is for sodium. Okay. We also know that there are diatomic molecules. What are our diatomic molecules? How many are there? 7. There's 7. So we have oxygen. What is that? That stupid thing I say to help you remember? Little L. There's not L, the 7 and the.
Isn't it something about
Something about beer, yes. Have no fear of ice cold beer. So,
make it better?
so I have fluorine, bromine. Nope, not boron.
Hydrogen?
So we have hydrogen, nitrogen, fluorine, Fluorine, bromine,
Sound like a
oxygen, iodine.
I am.
Nope.
In spirit.
That's seven, right? Okay, so let me add one more to it. So we also have a diatomic ion. So the diatomic ion that you guys have to be concerned with is mercury 1. Mercury 1. And you're going to ask me, what is mercury 1? The mercury 1 ion. And the way that we write that is, I want to write it down. We'll talk about it here in a second. Is Hg plus, okay, because it's diatomic, it's a diatomic ion that has a +1 charge. I'll share that screen here. 1 second. Okay. Okay, so that's the other one I wanted you guys to add on. You guys gotta remember that, right? Mercury 1 ion. Okay, so diatomics, you guys see the little 7 and H. Okay. Okay, so write the chemical formulas for chlorine, argon, bromine, and krypton. Okay, chlorine. Yeah, sure. I'll put money on it. Yeah. How much you want to put on it? Okay, put your $2 out. Let's see if I have $2. Oh, wait, I got $2 here. I got money in my money tank here. Come on, $2. Hey, who else is going to get in on this action? Me.
I have a Rice Krispie treat.
I have a Rice
Right there.
I don't want to bet.
Yeah, I have a Rice Krispie treat too. I'll bet you the Rice Krispie treat. I'll take two. Come on, put it on the table. Okay, so you got $1, okay? Okay, you got 5. 5 going on. I'll make a lot of money today. Okay, so we'll get to it here in a second. Argon.
Air.
AR. Bromine. BR. Are you sure?
Yeah.
Put money on it.
Yeah.
Okay, you already have your 5 on it. What's that on?
If that's the simple.
It's the chemical formula. We're gonna talk about the chemical formula. Oh, right. Not the symbol for the atom. We're talking about the chemical formula. That's the question asked. There's one way about this. So tell me why I would do the chemical formula, because the chemical formula should be what? Well, we just talked about it.
I don't know, but that's just a simple.
Okay.
It should be like style.
What was it? Say it again. Say it, come on, say it out loud.
Well, you are too.
It should be BR2. Why? Because it's a diatomic element, right? It is a diatomic element, and we're talking about the chemical formula. Is UDPR2. Thank you for your money. You're contributing to my education here, right?
Yeah.
Because we just talked about diatomic elements, right? When these things are in nature, they form a diatomic element, right? So when they're in nature, they form a diatomic element. We talked about the 7. That's the reason why you need to know it. You need to know that they're diatomic naturally, right? When they're by themselves, they're diatomic. You earned that money, didn't you? What's the dollar? I'll give you part of that money that I made, right? Come on now. Who's next? Who wanna contribute to Dr. Henry's fund here? Right now, come on. Oh, I'm taking your money. I'm taking it all. Because I want to make sure that you guys remember. You'll remember it, won't you? Oh, yeah. You'll remember it, won't you? Yeah, you lost $5 on it. Okay, Krypton, KR. Krypton, what is the symbol for Krypton? Get started, you know. Okay. Okay, so the thing is that we want to remember there are 7 diatomics. What are they? Give me one. What was it? 1. All you need is 1. Hydrogen. Thank you. Give me 1. He gave me hydrogen, a diatomic. We just talked about it. Come on now. Are you that old? Come on, Grandpa. Nitrogen. Thank you. She's so nice. You owe her $1. Give me 1. Tell your girlfriend I said hi. I'll talk to her later. Come on. Remember, so that when they're by themselves, we're talking about oxygen gas, it's O2. When we're talking about bromine, it's Br2. When we're talking about chlorine, it's Cl2. When we're talking about hydrogen, it's H2. Iodine. Okay, now what is the only diatomic ion? What is an ion again?
It's an isomer.
It has a charge to it. That was last week. You're like, that was last week, Dr. Henry. I got that one out, you know. Okay, so the only one is what? Mercury what?
1.
Mercury 1. So Mercury 1 ion. It's the only diatomic. Can we spell it for you? And we use the Roman numerals to signify the charge. We'll talk about that too. That's right. Oh, I'm trying to push your head. Kicking and screaming as you get up. Okay. Don't worry, I'll make sure it hurt a little bit more. Okay, so we know about metals and nonmetals. Okay. Now, on your periodic table, you guys can distinguish between metals and nonmetals, right? And then we have this order called the metalloid line, right? The metalloids are are elements that act like metals and act like non-metals. We talked about that a couple of times, right? So everybody has that down. Okay, so we have right now. I'm actually going to shift up things a little bit. We'll come back to it. Okay. So actually, we'll go ahead. Okay, so when we talk about nomenclature, there's what we call the binary molecular compounds. So basically meaning that it's composed of two words. Right now, this is true for the most part, but I'm going to kind of expand it out because you guys can do more than two words, because you guys are capable of more than two words, right? Okay. So when we talk about binary elements, and particularly compounds, we're often talking about covalent compounds. Now, there are going to be certain formulas or chemical compounds that we're going to be talking about that have common names, or what we call them common names. They're called traditional names in your book. Common names such as water, H2O. We know that we talked about H2O. H2O refers to water, right? Everybody knows that. If we talk about NH3, that is referring to ammonia. You guys are responsible for knowing this, right? Because H2O is water, right? NH3 is ammonia. Okay, so when we're talking about these elements, the way that we determine that the element is done, we put the term IDE at the end of it. IDE. Okay, so for instance, if we talk about carbon dioxide, okay, now that I lets us know that we're the end of that molecule. Now, often when we make that term molecule, what is the definition of a molecule that you guys know of up to this point? A molecule, was it? Okay, okay, more than one atom, okay, two or more atoms, okay? So it has to be two or more atoms. It could be just O2 or it could be CO2. Both of those would be considered a molecule, right?
What was the one if they're the same?
Okay. Now, often when we use the term molecular, we're making reference to two or more atoms, but we're talking more specifically about covalently bonded atoms. What is covalently bonded? What was that? What do you mean by that? What does covalent mean?
Electrons, the sharing,
Say it again.
the sharing of electrons.
It is the sharing of electrons. Now, we share electrons when we're non-metals or when we're metalloids. Metalloids can swing both ways, so they can also share electrons, okay? So non-metals are going to share electrons. So in this case, carbon and oxygen are both non-metals, right? Carbon and oxygen. Are they not non-metals? Okay, so they would form a covalent bond. Okay, now when we're talking about the nomenclature of covalent bonds or binary molecules, we're making reference to this type of nomenclature. Okay, now covalently bonded molecules, they're going to use what we call Greek prefixes. This here is a Greek prefix. Prefix comes before something, right? Prefix. Suffix at the end of something. I would be a suffix. Okay, so your Greek prefixes are mono, one, di for two, tri for three, tetra for four, hecta for five, hexa for six, hepta for seven, octa for eight, nona for nine, deca for 10, deca for 11, dodeca for 12, trideca for 13. Okay, so when we're talking about covalently bonded compounds, if there's only a single element for that first element, there's only one here. We don't use mono. We only use mono for if there's only a single element for that last element. So for instance, if I had CN, we would call this guy carbon mono nitride. Okay, or we drop the O G N and put I at the end.
Is
And
mono-
mono meaning one. Okay, so what would I call this guy? Okay, what about this guy? Hydrogen monoxide. Okay, questions? So let's make it a little bit harder. I have this guy. The decafluoride. How many sulfurs are there? So we say hexa, sulfur, no deca, fluoride. Okay. Prefixes. That's right. Okay. So covalently bonded compounds use prefixes. Okay. Covalently bonded compounds use prefixes. How do we know something's covalently bonded? Share something. Share what? They share electrons. Okay. Now who shares electrons? Okay, now you're running in circles. Right? What type of elements share electrons? So we said it earlier. Metalloids with, not with metals, non-metals. So non-metals and metalloids can share electrons, or just non-metals, right? Okay. Now, again, the way I look at it is, and I think I said this to you, if you guys were thieves, you remember that story? If you guys were thieves, would you steal from your neighbors?
No.
No, you steal from somebody across town, right? You wouldn't steal from your neighbor because your neighbor knows that you stole from him, right? So you want to share with your neighbor. You're like, hey, dude, let me borrow your phone, man, right? And he'd be like, oh yeah, sure. Okay, now if I kept his phone 99% of the time, that would be uneven sharing, right? We talked about that. Okay, we did talk about that. Okay, just like touchy base.
Your sister.
Okay, so let's give us let's put a couple up here so you guys can see.
Oh, yeah. You're lying.
One other thing, oxygen is kind of an odd stuff, right? He doesn't like to have. When there's vowels that are next to it, it won't put, like say we said mono. Mono, we won't put mono oxide. We put monoxide. Drop it. Okay, so we get rid of the O. If there's an A, we drop the A. No, so like for instance, if it's tetra oxide, we would just put tetroxide. Okay. Yes.
Trioxide.
Okay, that's good. Trioxide, right? So in that case, you still keep it because it's an I. So just the A and the O. Okay. The I's are going to be kept. Okay, so what would be the name of this here? Hepta, phosphorus, trioxide.
Can't tell me about girlfriend.
Okay. Okay. So if I have okay, what would be the chemical formula? Okay. Questions?
Is that SELR?
SE8CL6.
Look it up.
That's not what I'm looking at.
Look it up.
Where it says octus, the next word. What it has?
It's right there.
SELENIN. Octasolene.
You guys are helpful. Thanks.
Then stand up.
I'm gonna fuck you up. Give you what you found.
Okay, questions? Concerns?
Yeah, respect
Yeah.
your elders. Give up.
You guys like the little man.
Be good.
Right now. What'd you say?
Probably listen to
Okay.
the or something.
Ready to move on?
Understand his hand. So get him closer.
So when we're talking about ionic bonds, we no longer use those Greek prefixes for ionic. Okay, so we no longer use the Greek prefixes. So in the case of ionic bonds, group 1 metals, group 2 metals, you always know the charges. Group 1 metals are going to be what charge? Positive what? What is the rule? What are you trying to do? What is the goal? What is your goal in life as an element?
To be balanced.
We want balance, so we want some stability. So what would you do if you're group 1 metal? You would lose how many electrons? You would lose 1 electron. Why would you lose 1 electron? Because your valence has just 1. Yes, that's true, but why? Why do you want to lose 1? Who do you want to be like? Show you guys that video. Did I show you guys the video? I did show you the video. Okay. So I haven't gone crazy. Who do you want to be like? Somebody said the noble gases, right? I heard that. All right. Making things up.
Just remember.
Okay. So we want to be like the noble gases. So if you're sodium, right? You're 1 away from being a noble gas. You're going to lose that electron. Right? We talked about low energy, right? It's easier for you to lose rather than to try to gain 7.
It only means it's
Do you remember that?
because of that.
Okay, so it's easier for us to lose that 1 electron to be like, who are you going to be like if you're losing 1? Who are you going to be like? We're going to be like neon, right? If you lose 1, because you want to be like the noble gases. You want to be like the noble gases. Because you want to be like the noble gases, you want to lose that 1. Okay, so if you're calcium, what's going to be your charge? If you're forming an ion. Calcium? Where's calcium located at? Group 1, group 2?
It's
It's group 2. Okay, period 4. So it's group 2, period 4. So how far are you from being a noble gas? You're 2 away. So what's going to be your charge? +2. Okay, so group 1 is always going to be a +1 charge. Group 2 is always going to be a +2 charge. Because of that, we don't have to use Roman numerals for those guys. They're set. We know what they are all the time when they form ions. So, a hard one. I chose NaCl. What do you guys call that? Other than salt. Sodium.
Chloride.
Chloride. So again, we use I. I, in this case, has 2 purposes. 1, it tells us it is a negatively charged ion. 2, it tells us it is the end of the compound. Okay. And you notice we just use sodium. That's it. Sodium chloride. Nothing fancy. Okay. What about what do you think that's going to be called? Magnesium oxide. Okay. Now see the connection? Okay.
Yeah.
So tell me, magnesium, what is the charge on magnesium? Magnesium has is it positive or negative? Okay, because you're losing electrons. Look where magnesium is located at. Do me a favor, count to the nearest noble gas. 2. So then it's losing 2 electrons to get that +2 charge. Right? So magnesium would have a +2 charge. Oxygen, look where oxygen is at. How far is oxygen from being a noble gas? It's 2. Am I going to gain electrons or am I losing electrons? So what is going to be its charge? It's going to be a -2. You guys are just telling me 2. I need a positive or negative. Charge means it has to have a positive or negative charge. It can't just be 2. It has to be a +2 or a -2, right? Because this means I have 2 pluses. This means I have 2 minuses. Okay. Now, I talked to you guys about dating crackheads, haven't I? Yeah. Okay. I told you that I can't date crackheads because they're too much for me, right? Too much for me. Okay. Now, in this case, you have somebody who's a +2 and somebody who's a -2. If I put them together, do they balance out perfectly? Aren't they a happy couple? Okay, so they balance out perfectly. So in this case, all we have to do is call this magnesium oxide, right? And they're balanced out perfectly. Okay, now let's say they don't balance out perfectly, right? So let's take a look at magnesium chloride. What is the charge of chloride? 1. Positive or negative, because it's the charge, you gotta tell me. Negative. Okay, so we know it's Cl minus. Okay, and magnesium is 2 plus. So how many chlorides will I need to balance out? I just need 1. Are you telling me 2 minus 1 is equal to 0? I'll need 2 of these, right? So then I would write it as MgCl2. Now you'll notice there are no charges on the compound. When I write the compound, it doesn't have any charge because they're perfectly balanced. Does that make sense? So when we're talking about the compound, we call it magnesium chloride. You notice there's nothing that says ion, right? Okay, that means it's perfectly balanced. Okay, you see how we may put this out?
Yeah.
Okay, so let's see if you guys got it. You want a picture of it? You want a picture?
So it can't be made like,
It should always be balanced, yes. Okay, now you'll also notice that there are no Greek prefixes here either, right? See none, right? Just an H. So ionic bonds, we do not use Greek prefixes. I tried.
Try them.
What was it before? Learning, right? But it's at the end, so that's. Right, it is right. It's not all of it. Most of the time. This guy's not. Okay, you guys ready? So this first one, we'll get a chemical formula for it. Ca 2 C. Everybody agree? CaC2. No, it is correct because what is the charge on calcium? 2+. It is 2+, right? Ca2+. What is the charge on carbon?
Or negative.
Okay, look on your periodic table. Do me a favor, count from carbon to the nearest noble gas. So it's gaining 4 electrons. Right? So ions are just when they've gained or lost electrons, right? So nonmetals are going to be gaining electrons to try to be like the noble gases. Metals are going to be losing electrons to try to find stability, right? Either to be like a noble gas or to find a way of being stable. Okay, so calcium was going to be the charge of calcium. Okay, I'm looking at the wall. What's going to be the charge of calcium? 2, right? Yeah. Okay, and then count backwards. So then there's noble gas. Right. Right. So it'll go that way and then over, right? So calcium is here. Calcium is here. 1, 2. All right. Because look at the atomic number. That's 20, then 19, 8, 3. So 2.
Yeah.
Okay, does that make sense?
I'm tired of thinking.
Okay.
Which way did it go?
Strontium, nitride, SR, SR, 3, okay, and 2, fire. Okay. How did you get that? Tell me. Preach, brother, preach.
So the right side, probably writing them down. I put SR.
SR,
2 plus.
SR 2+.
To the right, I put N. 3 minus.
It's like, look at the-
They have to add up to 0, right?
Yeah.
That's 6. That's 6. Right? So that means I need 3 of these to balance out that. Okay. Yes, ma'am.
I'm not understanding.
Why? What is it that you don't understand? Let me wait. Look at this. I just want you to think simply. I have +2, +2, +2. Right? Is that equal? If I add those all up together. 6. If I have -3, what does that equal? But altogether it equals 0, right? At the end of the day, an ionic compound has to equal 0, right? We know that strontium has a +2 charge. Why does strontium has a +2 charge? Okay, so it's 2 away from being a noble gas, so we need to lose 2 electrons, right? Okay, and we know that nitrogen has a -3 charge, right? How do we know that nitrogen has a -3 charge? Okay, so we know those charges, right? We need to find a way of making them so that they're balanced, right? Because if they're not balanced, it's unstable, right? Remember I talked to you about crackheads, right? The reason why you don't make crackheads is because of their instability, right? You can never find their stable point. Now, if you can find their stable point, it would be okay, right? Because then you would be able to be stable. So if we have a +2 and a -3, just one of each, does that equal 0? No, we want to equal 0. How can we equal 0? Right? By having 3 of the strontiums and 2 of the nitrogens. I mean, what is it? You gotta help me not understand, right? So the charges. There's 2, 4, 6, right? So it has a +6 charge. This has a -6 charge, right? So we add those together, what do they equal?
I see it now.
You see it now? Okay. Looks like your periodic table. Where's nitrogen? How far is nitrogen from a noble gas? 3. So that means you're gaining how many electrons to get to there? Look what's nitrogen's atomic number. 3. Right? Its atomic number is what? Because we need 3 of them, right? 3, 2 plus charges. 1, 2, 3. Right? To add up to 6. Okay, so right now, look at this. If we just take one of these, right? This one here is a +2, right? This one is a -3. Thus, +2 - 3 equals 0.
So he showed you the S4, got SR3. But she doesn't, she's confused on how they got it.
Okay, wait.
It is an SR.
Each SR is 2 plus, right? If we look at just one, if we had just one of each, right? Will that equal 0? Because this is a 3 minus, and that's a 2 plus. Does that equal 0? No. We need to find a way to make them equal to each other, so they're balanced out. Okay, so if each of the SRs are +2, 2, 4, 6, right? So that's +6. Because each one is a +2 charge. If I had 2 + 2 + 2, what does that equal? 6.
Keep going. I don't know what I'm going.
Okay, so this is a -3, and this is a -3. We add these all together. 6 - 6 equals. That's for your number of electrons. That's to get the charge. The first thing that you have to do is get the charge. You need to know the charge. If you don't know the charge, you can't balance it out. First thing you do is get the charge. Figure out the charge of each of your ions. That is the first thing that you do. And then once you get that, you need to balance out the charges. They have to balance out. Okay, we got the charges, +2, right? So each one of these are a +2 charge, right? So at the end of the day, it has to equal 0. How can it equal 0? If this is +2 and that's -3, I can't have just one. I need more, right? I need to figure out the numbers that I need for each one. That makes sense?
Yeah.
Okay, what's the next one? Next one. Li3. Lithium. Awesome. So this time you drop the RUS, ORUS. It's lithium phosphide. Okay. So what is the charge on the lithium?
1.
Okay. And phosphorus,
-3.
-3. That's right, -3. 3 minus. Okay. So each of our lithium is a plus. Why do we need 3 of them?
Balance it out.
We need 3 of them because it balances it out.
Yeah.
That's how we end up 1, 2, 3. That's how we get that subscript, because there's 3 of them. Right? To balance out that negative charge. Okay? Last one.
Magnesium sulfide.
So he's trying to raise money back. That's what it is. He's like, I lost that damn dollar. I'm gonna earn every penny back now. That's right. Okay. Gonna try a couple more and then we'll move on.
Sure. Oh, it's work study. Work for the school. Yes, and she only gets 19 years and
Okay, you guys ready?
$1,000 a month. The one good thing, about working for Dr. Henry is that he was consider, okay, you have homework, you got class, you got exam, all right, you don't have to go, or this week, or next week. Yeah, because you're not making money. Yeah, that's why you gotta hire several. Because like if one of them is sick or gone or leaves, there's another one. Then they leave for another one. So at least that's the. You good? Yeah. Well, no, it's like, how does it, here's how it works, right? You hang out with like, become. Yes. And then it's like, and it's weird because then you talk to them and stuff. Yeah. Listen to that for seconds. Just do.
Okay.
But she doesn't know. Sponsored. It's real. I don't know if that's your chair. Good. Oh, we're doing exactly what we did. But extra dollars. Just like help out.
Later on. Not in this case, it's not a group one that, what is it? As, no, but there's a symbol. The letter. What is it? It's a what? What did I tell you about non-numbers? Covalent, and also what they'll say, that are they gonna pay electrons or are they gonna? They're gonna gain.
Just gotta find.
So it's how you gain electrons, you're gonna heat.
Where's Jerry?
You're gonna gain one electron. It's gonna
Jerry? Yes.
helium.
Period 6.
If it loses one, who's it gonna be like?
Thank you.
No, it's gonna be something different. Actually. And it does, there are situations that it does lose. They talk about that. We're building up.
Right?
Try.
No, it's H. Sorry, but that's- But what would we charge them? If I'm getting-
To the back.
Yes.
Three. And.
You ready?
Yes.
No.
Were you able to get the number today? Were you able to get the example? Yeah, it's funny how that works. I was taking an online class or something. Harvard out 2 days.
Well, somebody would.
Okay, you guys ready? Okay, so what would be the chemical formula for sodium silicide? Fa. Na, okay, I went. Four. Are you sure?
Yeah.
Si.
Yeah. Me, you say yes.
Okay. What about the next one?
CS2. Oh,
S2. Oh, I thought you guys said, oh, as in.
oh,
Okay. What about barium nitride?
N2.
Okay. What about lithium hydride?
LiH.
What is this? Okay. Questions? Concerns? Okay, tell me, what is the charge on the nitrogen? Okay. And what is the charge on the barium? Okay, so I want them to balance out. How many barium do I need to balance out? Right? And then how many nitrogen? Okay. So they cancel out, add up to 0. Another way, a quick way of doing it is
It's plus 5 when it's just one. Plus 5 when it's 3. Plus 5 when it's 3. When,
okay. So
plus 5 was 5.
barium 3. That's another way. Well, if they're not multiple substitutes, right? So for instance, this K here, we're only looking. That's right. Okay, yeah. Although that does work out for this one. I don't think it does. In certain cases it does. Yeah. How are you guys feeling so far? Not too bad? Okay, so let's add a layer. Well, before we add a layer, when we talk about the ions alone, let's say we're talking about lithium, and it would be lithium plus, and it's written as lithium plus, right? Li plus, we would call this the lithium ion. That's all we call it. If you want to be more specific, you could say the lithium cation, but the lithium ion. So we're talking about the ion alone, we say lithium ion. That's how we write it. If we talk about nitride, we call this the nitride ion. Add ion. Nitride.
Minus up there.
Yes, because you're letting me know that it's the ion. Because if you just put in, that's not nitride ion, that's nitrogen. And if we're talking about the formula nitrogen, okay, so ready for the next level? Oh, it is. So all of these are called monoatomic ions, right? So these are, this here is a monoatomic ion. What do you think it's called? Monoatomic.
31.
That's right. Monoatomic, right? There's only one. What?
All of these were mono, right?
Yeah, so, well, there are two monatomic ions coming together. Okay, we will get to polyatomic. But first, before we do that, we need to talk about those transition metals. So remember, I told you, and I will tell you again, that transitional metals are a hot mess, right? I said transitional metals are a hot mess. The reason why transitional metals are a hot mess is because they have the ability to have multiple charges. Let me give you an example. We have iron. We have iron 1. We have iron 2. We have iron 3. And we have iron 4. Iron 1, the iron 1 ion has a +1 charge. The iron 2 ion has a 2+ charge. The iron 3 ion has a 3+ charge, and the iron 4 ion has a 4+ charge. Okay, now the way that we name transitional metals is we say what element is, we give them a Roman numeral to tell me the charge that the ion is. Okay, so do you guys know your Roman numerals?
Yeah.
Okay, so what is the Roman numeral for 1? I. Okay, Roman numeral for 2. I. Okay, Roman numeral for 3. I. Roman numeral for 4. I, B. Roman numeral for 5.
B.
B.
Roman is X, 15 is X.
Roman numeral for 7. B, I. Roman numeral for 8. B, I. Roman numeral for 9. I, X. Roman numeral for 10. Okay. So you're going to use the Roman numeral to tell me what? The charge. Okay. Say it again because you'll forget it. You're going to use the Roman numeral to tell me what? Charge. Say it one more time. You're going to use the Roman numeral to tell me what? Charge. Okay. Now I'm going to test this out. Oops, sorry. Okay, can I erase this? Okay, so what would be the name of this ion? It's a C, CD. CD.
Bro, that looks like a
Stop making fun of my C.
It looks,
God.
hold on, it looks like a sign. It looks like a sign for the never mind.
Cadmium. Cadmium. Okay. So it's cadmium. Cadmium. And iodine. Okay.
You always have to put ion.
Yes, if it's the ion, you have to use an ion.
Yeah. What's part of that?
Okay. Questions? Concerns? Ready now? We're gonna do some later. Okay? Now we know how to do the ions, right? Let's see if we can put it together.
So you get to end class, I swim because I did the marching. I did it trying to so what you breathe,
That's an S. OS. Sure.
like we had a fire. I was working with, yeah, these guys that
Yeah.
I'm getting care of like class, just like drop it. Stuck around. Yeah. There we go, Mr. Singh. There's the two, right? No, Mr. Singh. The real one. I've lived with it on my sure used to have a cheater. Every time you pass by now, it smells like shit. For 10 years. For 10 years. Sounds by it. Passed by this again. And apparently it's like a flood. Once in a while. You know what the bed houses now? So you go smooth first.
And I should say this Roman numeral applies for post-transitional metals. They can also apply for metalloids if the metalloid is acting like a metal. And they can apply for lactanoids and actinoids. How map those orders. The 3D structure. Okay. Okay. What should I do about that?
I'm really supposed to look for the first part. It's osmotic. Put the Roman 6 parentheses oxide. I like citric oxide.
It's not oxygen.
What is the last part? What is that last part? That's oxygen. So next to it is oxygen. Oh yeah. Well, the osmium is like a metal. Well, it says- oh,
I was asking if the O3 was oxygen.
yeah, all three is oxygen. It's the oxygen. What? I mean, I write it down how he showed us. I don't know if it's accurate. Just like the osmium parentheses aluminum 6 oxide. Although I assume that the charge now or no. Top plus or negative? No. I mean, no, look at those last two. Look at those last two. And on the side, there's nothing there. I think we only put the positively charged on it. And we only leave it. I need to see how the first one. The second lesson might be it's engine. Well, then, positive too. Wait. Should be positive. Well, I should. Maybe there's.
Okay. Okay. So, you guys ready? Ready? Okay, so let's go. First one. Are you missing anything? No, not trioxide. No Greek prefixes. Those Greek prefixes. Say that for me. Okay, not for ionic compounds. Okay, so how do I tell you the charge of osmium? I need a Roman numeral. What Roman numeral do I need? Okay, so what is the rule? The Roman numeral tells me what? The charge of osmium. Tells me the charge of osmium in this case, or the metal, or transitional metal. So what is going to be the charge on the transitional metal? Sure. Okay, so you're telling me, this is what you're telling me. OS 1 equals O2 minus O2 minus O2 minus. No, it doesn't. So in this case, again, osmium is a transitional metal. Their charges are not going to try to be like a noble gas. They are a hot message. They're not trying to be like a noble gas. They find other ways of being stable, right? And so they have specialized charges. So you have to pay attention to who they're paired up with. Who is osmium paired up with? And how many are there? There's 3, right? So then what has to be the charge of osmium if there's no charge on the compound? What was that? That is 3. Are you sure? That's 2, that's 4, that's 6. It has to be a +6 charge. Yes, 6 plus charge, right? Okay, so the Roman numeral would be 6. Okay, so with the transitional metals, we have to figure out who they're paired up with and the charges of who they're paired up with to determine what their charge is. Does that make sense? Okay. Somewhat.
So it's basically sort of the same thing that we've been doing,
Exactly.
except we're just writing it as a.
Yes, you're letting me know what the charge is, right? Because with transitional metals, lactanoids, actinoids, post-transitional metals, and metalloids, you have to tell me what their charges are when they're pairing up with their partners. Okay, so knowing that, what about this one? Okay, so it'd be tungsten 9. Tungsten.
That's 3 negatives. Okay, 3 on both sides, and they're negative, right? So it'd be 9. Then you have to balance it out. So
You could try to explain it, but I can see it.
Okay.
I appreciate it.
So tungsten. We have a question mark here. That's a question mark. Okay. So what is nitrogen? What is the charge of each of the nitrogen? Okay. So it's Negative? Negative what?
Three.
Okay, so 3 negatives, right? How many do we have? We have 3 of them. Okay, so what has to be the charge on tungsten to balance out -3, -3, -3?
What is the charge?
That's what you're figuring out.
Hold on, let me try.
Okay, so,
Five.
no. So again, transitional metals, the reason why they're hot messes is because they don't obey the octet rule. They don't want to be like noble gases. They have their own special way of trying to being stable, right? They're a hot mess, right? Hence change, right? Transition means change, right? So because they're changing, they can change their charge depending on who they're with and what they're doing, how you play around with them, right?
Yeah.
They can have different charges. So you have to pay attention to who they're with to determine their charge. So in this case, there were nitrogen, and there's 3 of them. So what has to be the charge?
Tungsten 9.
Tungsten 9. So
Let's go. So all you're doing is adding up, so like for the first one, OS and O3, all you're doing is using the O3.
that's right.
Alright, for sure. And then you'll just add it up and put it on the other side.
And yes, and you use that to determine the charge on that.
Show.
Okay? So the next one is the O3E2. Okay, so in this case, we know we have 3 cobalts. Okay, and we have phosphates. What is the charge of your phosphates? Okay, so this adds up to what? -6. -6 divided by 3. These 2, so that each one has to be. Okay. No problem. Questions, concerns, Cash? Kool-Aid? Okay, are you feeling it? You got it. Going to go for it a little bit more, and then we'll move on.
Yeah, listen.
A little bit more.
No. Let's do the rest.
Oh, shit. The others, we had finished. Yeah, I don't remember what they were. You gotta tell me what they were.
Mercury, 1, fluoride.
So mercury, 2 chloride. Mercury, 1 chloride.
Because it becomes.
And so what's the other? Your dad. Okay, so mercury combined with fluoride.
Lila.
Okay, so we got
Hg plus
Oh, yeah.
do I put a plus? If it's
You
balanced,
see the
plus.
movie at 9/11,
just Hg.
the original version, but then they had to change it because the
Sure.
9/11 did that. It was from 2001.
Come on, somebody said, wouldn't it?
I was
Wouldn't it? What?
I was in 9/11.
What was that?
I was in.
Okay, so what do we know about mercury 1? What do we know about mercury 1? We talked about it at the very beginning.
Okay, so
Oh, this was shit.
it's
But then this is like a 2+1. The
Okay,
original
so
was
if the mercury
was
is
$15. And
two
the
plus, number two, then how many chlorides do I need to balance it out? I would need two, so it should be Cl2. Because it's diatomic. It is a diatomic ion, so it always has to be written as
was not.
set you up, like that damn bastard. I knew you were gonna do it. Expect to see that one on the exam. Saying. Okay, what about gold carbide, gold 3 carbide? AU. That's C4. Okay, so let's look at it, right? What is the charge on the AU? AU, so what would be the charge on? Okay, so it's 3 plus.
Question.
And then what would be the charge on the carbide? -4. So if I do it like this, so then my answer should be AU what? AU4. Because the Roman numeral tells us the charge on the gold. The gold is a +3, right? And we know that carbide is a -4. So we can do that cross multiplying thing, right? And end up with our. Now we can move on. Want to try some more? Okay.
It works. Everything.
Okay, so let's go ahead. We're going to take a break and then we'll come back and we'll do some more because it gives your mind a little bit of a moment.
It counts how many
a little bit. And we'll take it, right?
Without, if you don't have that information, you do that.
Okay, so then we'll see you guys. And then we'll go over this. We'll go over hydrates and then we'll go over acids. Okay, so notice I diatomic ion.
Oh, God.
Mercury 1. Diatomic ion. 2.
I'm wrong.
No, but your answer is right. It is mercury 2. So you call this mercury 2.
Yeah, that will be
And it will be is that what you got?
I did
I
take
mean,
that.
I got, okay, so for SI, I got a charge of -4, but I couldn't figure out what each two.
Okay, so there's 2 of them. Each one is a +2 charge. So it's 2.
Because there's 2 of them, it's a plus charge.
That's right. Because it always has to add up to.
But if,
-4,
but if it were a 4, then that means that there would be a, wait a minute.
Okay, this guy is a -4, right?
For sure.
-4. There's 2 of these, right? So if there's 2 of these, each one has to be what? Before it's down to top. So 2 times +2 is going to be a 4. Is that going to equal 0? So each one has to be a +2 charge. Make sense?
Yeah.
What about the next one?
3, what?
I'm going to spell technique, what was the charge? 3. Okay, So if each one is Cl minus, Cl minus, we have one Tc. So what has to be the charge for the balance out? Has to be 3 plus. Okay. What about the next one? Okay. Next one. What would be the chemical formula? Okay, so my CE is going to be a +3. And my phosphide is start to my phosphide. Okay, so it's a -3 phosphide. So what is the chemical formula? I think we're Roman numeral 3, right? So what would be the chemical formula? You're doing the chemical formula. You need to give it a chemical formula first. CEP3. That balance out. This is a +3 and that's a -3. So there's one of each, right? So it'd be CEP.
What about the letter? Okay, see, I got the wrong element. I did too, I was, yeah.
Okay. And then the last one. What would be the name of it? Barium. Arsenide. Okay, so would I put a Roman numeral? Sure.
They call it sour.
Okay, group 2 metals. Group 2 metals. What is the charge on group 2 metals? Is it barium or group 2 metal? Okay, group 1 and group 2 metals, we never put Roman numerals on it because we always know group 2 metals are always going to have a charge. A +2. Group 1 metals are always going to have a charge. +1. So we never put Roman numerals on those guys. So it's called barium arsenide. Group 1 is always going to be a +1 charge. Okay? Group 1 metals are always going to be a +1 charge. Group 2 metals are always going to be a +2 charge. Okay, questions, concerns, cash, Kool-Aid. Okay, ready to report? The next thing that we're going to talk about is polyatomic ions. Favorite? You guys go to your packet. It is the 5th page in your packet. Not in your periodic table packet. 5th page in the periodic table packet. Not 5 sheets of paper, the 5th page. Double-sided. There you go, right here. That's it. It says common polyatomic ions. It says common polyatomic ions. Maybe it's the 6th page. Okay, everybody sees it? Okay, so these are your polyatomic ions. A polyatomic ion is polyatomic, meaning poly. Okay, so it's many atoms to make an ion. Okay, now these atoms in most cases are covalently bonded, but they have a charge associated. The ones that end with oxygen, let's say PO4, 3 minus, this guy, these are called oxy and ions. Why do you think they're called oxy and ions? Because they're polyatomic ions that have oxygen. And they're negatively charged because it's an ion, right? Okay. This oxy anion is called phosphate. So if it ends with an ANT, that's usually like our starting point. That's our entry point. If it ends with an INT, ITE, ITE, so phosphate, we lose one oxygen. If we lose an additional oxygen, it's below the phosphate, so we call it hypophosphite. If it's above the phosphate, one oxygen more, equals 5, 3 minus, we call that per. Like hyperphosphate. Okay? You guys got that? Per. Say per. Per. So it's one additional oxygen above. Okay. So let's say we have AR, AS, SO. Things that are in the same group are going to behave very similarly. Right? Things that are in the same group are going to behave very similarly. So if we look at group 15, we have phosphate, and we have phosphorus, and we have arsenic. Is that true?
Yes.
Okay. So we know for phosphorus, if it was PO4 3 minus, it was called phosphate. So since we know that, we would expect this guy to be called phos. What is AS? Arsenate, right? So we call this guy arsenate. Okay, so if it's AS 0,3 minus, we would call that arsenite. If it's AS 0,2 minus, 3 minus, 0,2, 3 minus, call that hypo. And if it's AS 0,5, 3 minus, per arsenate. Okay. Questions? Concerns? Cash? Okay. Okay, so now you know how to use the polyatomic ions. And if I ask you the chemical formula for the polonate ion, what is that going to look like? Polonate. Where's polonium located? Group 16. So it's going to behave like who else is in group 16? No, group 16 is not noble gases. Group 18 is noble gases. Sulfur. Okay, so sulfur is a common one. So let's look for something sulfur. So what would sulfate be called? I mean, what is the chemical formula for sulfate? If they have the ATE, they have the oxygen. Most of them are some exceptions. Sulfate. Sulfate. Look at your polyatomic ion table. That's why I gave it to you. SO sulfate, not sulfite or sulfate. SO4. Right? Okay, so then what would we expect polonate to look like there? Since it's in the same group. Polonate. In the same group. The sulfate looks like SO4 minus what we expect polonate to look like. PO, E lowercase o, capital O, and how many? -4. And be -2, and then how many oxygens? How many does sulfate have? Four. Because they behave very similar to the ones in the same group. You guys are making me laugh because I just tell you that and you ignore everything I said. Oh, fuck it, we ain't gonna tell me anything I want to know, right? So if it's in the same group, it's gonna behave the same way, except nitrogen. We look at nitrogen. What is NO3 minus? Yes, right. It's nitrate. Right? You notice it has a single minus. It doesn't have a 3 minus. It's in the same group as the phosphate, right? So it is an exception. It does its own little thing. Okay. Questions? Concerns?
Yes.
Yes.
So how do we get? I don't understand.
Because we looked at our polyatomic ion table. What does it say on our polyatomic ion? Nitrogen. What is the chemical formula for nitrogen?
It's just NO3 minus.
NO3, 1 minus, a single minus, right? Okay, so we know that it's going to be NO3 minus. That is the chemical formula for nitrogen. Okay, it's an exception because we know that phosphate has 3 minus up here and starts with 4 oxygen. Okay? And they're in the same group. Nitrogen is the exception. Nitrogen will be the exception for a couple of things. Okay. Okay. Questions? Yes.
Could you go back and show us how you did the
Okay. What group is polonium? Polonium. What group? It's in group 16. Who else in group 16 do we have on our polyatomic ion? Okay, so we have one sulfur, which is we call sulfate, right? So what is the chemical formula for sulfate? Look on your polyatomic ion.
-2.
Okay, so we know that sulfate looks like this. Since polonate is in the same group, and I told you that they behave the same way, how many oxygen do we expect polonate to have?
What?
That's right, 4. Okay, so that's how we got 4. What charge will we expect polonate to have? -2, because they're in the same group. Okay, so again, if they're in the same group, we expect them to behave similarly, right? Does that make sense?
It does.
Okay. Okay, so now that you guys know that, let's do some testing here. We're gonna test those skills. So I want you to give me the name of these ions. Using your polyatomic ion table and using your incredible brains, okay? Your incredible brains. I know that they're good. I know it. I feel it. Put it in my bones. Okay, you guys ready? Okay. So I want okay. Okay.
Just get it on research.
Okay, you guys ready? If they don't have oxygen, they won't have it.
That's the two.
Yes. So
You gotta restart it. Oh.
although we can start it. Okay, so that's two, so this is gonna be one. Okay, so let's go. That's so. That's so. Okay. Ready?
Yes.
Okay, so ammonia. NH4 NH4. Okay. Per telluric. Hypo dichromite. Bless you. If you don't want to answer, you're gonna have to sneeze all over everybody. CR2. 5 O5 minus. Are you confident? You're not? I'm saying you don't put money on it? Okay, so you don't put money on, never mind. That's right. Yes. It's gambling cash, gotta bring cash, come on, gas money, right? Okay, Edward. Come on.
Yeah, if I'm gonna be honest with you, I'm actually pretty lost now.
Pretty lost now. Well, you didn't make sure you get down, right?
Yeah.
Okay, so it's gonna help us. Go ahead. That's nice. Okay. Negative. Okay, because it has to be like, who else was in that group? It's also on there. Who? Silicon, who else is in the state of silicon? Okay. Carbon. So we know that carbonate is C3 minus. Okay. Oxalate. Can I get up in the track?
This shows C2O4 3 minus.
C2O4. 3 minus?
3 minus.
Sure.
No.
Okay. What is the charge on carbon or oxalate? ATE.
2 minus 4.
2 minus, right? And then it's C2O4. So if it's ITE, that means we drop 1 oxygen. So what should be that number? 3. But ATE, that's our starting point. ITE would be 1 below that. Hypo ITE would be 2 below that. Okay, hydronium. I'm going to give you this one. This is my freebie. Hydronium is H3O+. So you can put that one on your polyatomic ion. You can write it on your polyatomic ion. Okay. Okay, so how can we use this? In our everyday lives. Actually, you can't. Okay, let's talk about how we use it. So let's say we have chromium 4. Okay. Or telluric. Everybody else got this down before I started this. So we know that telluric is TeO5, 2 minus. Chromium 4, what is the charge of chromium 4? Symbol for chromium? Symbol for chromium? Are. And we know that it's a 4 plus, right? Okay, so how many tellurium, tellurates will I need? I will need 2 of those. Okay, so the way I would write the formula would be CR parentheses E over 5. Okay, so we use the parentheses because it is a polyatomic ion. It is together. It's moving together. It's acting together. Okay, so these guys are together, and there's 2 of them. Does that make sense? Okay, so if I want to write magnesium phosphate, what would be the chemical formula for magnesium phosphate? Okay, magnesium phosphate.
-2.
Mg,
-2.
yeah. Got it? Okay, what is the charge on the PO4? Look on your polyatomic ion table. What is the charge of?
3 negative.
3 negative. Okay, what is the charge on magnesium? Plus, right? Okay, so you can do that across both class stuff, right? Okay, so then this guy has 3, this guy has 2. Good. There now? Okay. I'll try one more and then we'll move on. Okay, ready? Make a part 2. Ready? Okay. Everybody got this down? Yeah, it's everything's possible. Everything, we can't have it. Okay. Aluminum hypochlorite. What was that? Aluminum is -5.
AL.
AL. What is the charge of aluminum? Okay, go the other way. What was that? Go the other way, which would be shorter. Okay, so we know that aluminum is a 3+. That's right. Okay, so then hypochlorite, is that? Charge on. See how low? Negative. Okay, so then how many of these are we going to need to balance out those? How many? 3. Okay, so then the answer would be AL, LO, parentheses, 3. Okay, everybody get that? Okay. Ready to move forward? We can do one more. Then we move forward. There we go. We're like that last. Everybody got this down?
2 and 1. Steps.
Yeah.
2 and 1.
Oh, I get you.
I was in M, I was in- I was in M1. Cover up your eyes. Can't fall asleep on. Okay?
Yeah.
Like you can't be crying because of you don't know nomenclature.
No, I'm not crying.
Okay. Okay, what do we got? Okay. Okay. charge?
Obviously positive.
It's a positive, right? It's the metal. That'll be positive. Okay, so then,
O negative.
okay, then how many am I gonna need to balance this out? What is the number here? How many is here? Okay, so how many of these am I gonna need? Oh, those are the two. Oh, you got it. I took care of it. I'm gonna need 3 of these. So,
Then it's gonna be parentheses. Parentheses. Positive four? Or are you gonna put something in?
parentheses,
Why is it inside?
because these, it's a unit, it moves together, it is a unit, it can't be separated. The unit. Units together. Unit. Okay,
Look at the time.
guys, good. Ready to move forward?
Yes, sir.
Oh, there's more. We're almost there. We got 2 major more things. One of them was really easy, the other one's really hard. Oh, don't worry about it. Tons in 15 minutes.
15
Actually, we got, it's 25 minutes.
We're on the clock, man.
No, that's, according to my clock, you guys are out at 10:05. That was according to the clock that they gave me.
It is 9:50. It went like 50. You went overtime before. The practice. Maybe.
According to the syllabus, it's 9:50.
Okay, so the next thing that we're gonna talk about is our hydrate.
According to the hours of overtime. It's fine.
So when you hydrate, what do you do when you hydrate? You drink water.
Yeah.
Guess what compounds do when they hydrate? You add water. So let's say we have this. Okay, so this is the way that we write that formula. The way that we would name it is fluoride. Di. So now we start using those prefixes to tell us how many waters we have in our hydrate. Okay, Greek prefix. So it's barium chloride dihydrate. You see that? So if I have this guy, okay, what would be the name of this guy? Sure. Put your money on the table. Iron chloride. Chloride, and then you guys said. And then are you missing something? Tell me, are you missing something? What are we missing? What number should it be? That's right. Iron 3 chloride, known as hydrate. Is that hard? Go one more.
No.
I mean, we're here anyway.
No.
I always laugh. Okay, let's do. Okay.
Carbohydrate.
Here, 11. Okay, first part. Oh, we know that. You like it better when I write it down. I do it both ways. Okay, Ricky, you got it? Yes. No? Okay, you want me to explain it? Okay, so we know the charge on the vanadium, right? It is a 3+, right? We know the charge on sulfate. It is a 2-. Right? So I can do that cross multiply thing, or I can do plus SO4 minus SO4 minus. At the end of the day, it's at 6, it's at a -6, and that equals 0. It has to equal 0. Okay? So we put 2 here, 3 there. It's a unit. Yeah, but it's a unit. So I'm sorry, I forgot my board. That's what you're saying right there. I forgot my board, right? But it's a unit. This is all one unit. Right? It's working together. It has a -2 charge. All together, it has a -2 charge. No, because the B has a 2. There's a 2 here. I mean, there's 1, there's 2. There's 2 B's, right? This here, that's together. Yeah, that tells me how many possible. Right? But that's together. SO4 together is going to have a 2- charge all together. One unit. Okay. You're looking at a single unit. Okay. 1 unit. Okay. So 1, 2, 3. Looking at the charge on that first unit, it's going to be -6 altogether. That's on the 7. Right? That's SO4. Okay. Okay. Are we ready to go home? Okay. I will say the last one for you guys on Wednesday.
Thank you.